Hey everybody. Alright, today we're going to learn something new. We've been going over the same stuff for a little bit too long now. It's time to dip our feet into something new. So we're going to start on program control instructions. Program control instructions is your chapter 9 in your book. So, what are program control instructions? Well, they can do a couple different things for us. One of the things they can do is they can disable or enable a section of the program. And we'll see that later. Another thing they can do is they can jump over blocks of logics. Blocks of logics being like this. This would be considered a block of logic. And lastly, we can even use them to switch entirely new programs. So let's say we had another program other than this one. Well, we could use that to switch to that entirely new program and have it run off of that. Okay. So to understand this, we're gonna have to get a really, really good understanding of the scan time and the scan process. Now, we talked about it in class before. We talked about the scan process, where essentially things go through one part of the PLC and then they scan the next. And we're going to have to talk about that in detail again, just so you can get a really good understanding about what's actually going on here. But first, I think it's actually a good idea to actually talk about what this is. Now, I have a emulated RS Logix program. So I don't really have a PLC attached to this thing. I only have emulated buttons and inputs and everything else. Now I can run this just like anything else, and I can even activate these. But to do that, I'm gonna have to right click and toggle a bit. Essentially, it's easy, but and it's not pressing a button. But that's how we can turn stuff on. And see, I just made everything turn green. So, instruction scan. So, what did we talk about before? We talked that the program scans itself first by going horizontal, like this, and then reading the first line of code. And here it's saying push button 1, and it is seeing that push button 1 is not activated, and so it is flipping bit 3 to 0. Or, well, this is actually bit 0 to 0. It's making it false. And this goes all the way down, and it keeps on doing that. So we start here, and we go to the right, and then it goes to the next line, and it goes to the right, just like you read. It's the same way for your program. Your program reads from left to right, up to down. So let's test this real fast and see if it works. Right, look, this turns on this bit right here. This bit is connected right here, and then turns this one on, and then it turns this one on, and then that one turns this one, and this one turns that one, and this one turns on our red light, our fake red light at the end. Here's another example. Okay. So what we have here is a switch connected to an MCR, another switch connected to a timer, and that same switch connected to another timer, an RTO. This one's a TON and this one's an RTO. Down here we have two done bits from each timer. Each timer is controlling an output. And last we have a reset for this retention timer, because if we don't have a reset, it'll never reset. So first up, I'm going to flip these switches and see what happens. Flip the switch, and these are true. These are both true, but their timers that they're connected to are not timing. They're not timing right. That's because our master control relay is not letting these time. It's just not letting. So if we want them to start timing, I'm going to turn on the switch for this master control relay. And now that it's on, it's now letting everything count. Right? And this switches, and this one switches, and then both of the done bits get done. Okay, so what happens when I turn this off again? I'm going to turn this master control relay off. And now it is off. Well, as you can see, for output 0, which is connected to timer 1's done bit, that one turned off, because this done bit turned off. And that's because this lost connection, even though this has a true. This is not allowed to make that done bit. But you'll notice that the retentive timer's done bit is continuing to transmit that it's done. And it's because it does not need for this line to tell it that it's done or not done. That is one of the differences of the retentive. And it will not change until I reset it. The reset. But it will not count again. It's not going to count up because this MCR is still controlling between these two MCR commands. What's most important here is to take away that there are an order of operations to this thing. And we're going to see if we can mess up that order of operations. So I'm going to go up here, I'm going to go offline, go to program mode. I don't need to save these, I don't know why I'm doing it, but I'm doing it. So I'm going to go offline. I'm going to see if I can mess this thing up. And the way I'm going to do that is I'm going to insert a new line. I'm going to take this new line, and I'm going to call this I0. So I have to, for me to make this work on my end, I have to type in the data table. So I'm addressing straight to data tables, since I don't have a real input to input to. And I will call this 1. And I've already addressed this as a PB2. We are going to take an output here, and for this output, I want it to show off this feature or this bug, or I'm going to take this relay and make it the same name as this one. All right, let's run this thing. I'm going to download. Go online. Run. Okay. So what do you think is going to happen? Well, let's try this button right here first. I'm going to toggle the bit on this one. Boom. This one turns on right here. And then it goes over here and turns this one on. And then they go all the way down to our red line. And I'm turning it off. Alright. So what do you think will happen to this one? Now, I think a lot of us believe that we would turn this on, and it will turn this one on, and then it's going to go down just like normal. Let's see. What's happening here? Shouldn't this turn this binary on, and that binary turn this one on, all the way down to red light? Well, the truth is, this thing is, in fact, turning this on. But the scan time is left to right, up to down. So we're going up to here, and this is saying, turn this on, and it turns it on. It does. We can't see it, but it turns it on. In the next line, it goes, well, this is not true. So make sure that this is not true. And so our binary is at 0. It's at 0 in this binary table. Let's see if I can get at it. Ooh. 0. Right? So this is why you have to understand the scan process. Is because if you do something after something, it can affect it. Okay, just to show you that this problem right here is that the PB2 is turning this binary off right here. This PB2 is turning this binary off. I'm going to get rid of it and see if that fixes the problem. So I'm going to go offline. You should know that you probably do not see my menu items here. But there is a menu here. So if you're wondering what I'm clicking, this is actually a menu for me. I'm going to go offline. And I'm going to get rid of this. And we're going to see if that fixes it. Put it back in run mode. And toggle the bit. We have fixed it. That's because we are not telling it to turn off in the next line. Keep this principle in mind for this upcoming couple of things we're going to talk about. Because it makes a difference in the end. Okay, so I'm going to show you the 3 program types we're going to be working with today. These are instructions. So to get to these, you travel your little box over here all the way from user to program control, because we're in the program control chapter. The first one we're going to talk about is the MCR, also known as the Master Control Reset or Relay. I've seen people use both names. MCR. The MCR essentially controls portions of a program. It can turn portions of a program on and off. Okay, the next thing we're going to look at will be a jump to label, a jump command. This jump command will be used to skip over pieces of the program into another area, and we decide what area that is by using the label instruction. So our jump will jump towards our label, and we'll see all these things when we get to them. Okay, so what I have built here is a very simple program. It has a couple of inputs, and they all control different lines of code. Except this one up here. This one controls a MCR, Master Control Relay. And you'll notice that there's another Master Control Relay down here, and nothing's actually turning this one on or off, right? So, while the Master Control Relay is on, it's going to let the outputs of these be energized. See? The outputs are energized, just as normal. But, if we turn this off, we turn off this MCR. Look. These inputs are true, but it will not let our outputs become true. That's what the MCR essentially does. The MCR controls a block of code from letting their outputs turn on. But it only controls a block. If you imagine this right here, and this line right here being a block, that's all that this controls. Because if I try one of these down here, these will turn on as normal, right? They turn on as normal. Because they are outside of the block of the MCR. Now what do you think will happen if I turn this MCR back on? We can let our outputs turn on now. So this is essentially what the MCR does. It controls blocks of code. Here's another example. Okay. So what we have here is a switch connected to an MCR, another switch connected to a timer, and that same switch connected to another timer, an RTO. This one's a TON and this one's an RTO. Down here we have two done bits from each timer. Each timer is controlling an output. And last we have a reset for this retentive timer, because if we don't have a reset, it'll never reset. So first up, I'm going to flip these switches and see what happens. Flip switch, and these are true. These are both true, but their timers that they're connected to are not timing. They're not timing right. That's because our master control relay is not letting these time. It's just not letting. So if we want them to start timing, I have to turn on, I'm going to turn on the switch for this master control relay. And now that it's on, it's now letting everything count. Right? And this switches, and this one switches, and then both of the done bits get done. Okay, so what happens when I turn this off again? I'm going to turn this master control relay off. And now it is off. Well, as you can see, for output 0, which is connected to timer 1's done bit, that one turned off. Because this done bit turned off. And that's because this lost connection, even though this has a true. This is not allowed to make that done bit. But you'll notice that the retentive timer's done bit is continuing to transmit that as done. And it's because it does not need for this line to tell it that it is done or not done. That is one of the differences of the retentive. And it will not change until I reset it. With the reset. But it will not count again. It's not going to count up because this MCR is still controlling between these two MCRs.